let's get going. I think most of us just got off the 224N class where Joseph took us through, I think, Steve's notebook. So, Steve, do you just want to quickly summarize um, kind of what you attempted and what you got with the BERT approach with using BERT for this particular task?
Yeah, so it was just taking like one of the TensorFlow example notebooks. In their case, they were using the notebook to compare two sentences to say if they were similar or not. So yeah, I just took the Kaggle data from the Quora question pairs and put it into that notebook, and like then used exactly the same classification mechanism to say if there were duplicate questions. I'm not sure why. The results were better than I got with the classifier using the universal sentence encoder, but the results I'm getting are still, they haven't actually put me into the top 1,000 of Kaggle leaderboard yet, so there's still like a lot of a way to go. The other thing I tried was like Gautam's idea of swapping the question 1 and question 2 to effectively like double the training size, and it's like something I just tried very quickly there, like in the last couple of days. But yeah, so far with that, the results got worse, which I'm not sure why that is, but it does seem very temperamental and very susceptible to like overfitting with it. Plus, as well, within the TensorFlow set of available BERT models, they have a various sort of set. Some are for uppercase, and some are like for lowercase, and some are for, it doesn't matter what the case is. So perhaps I haven't chosen the right model or whatever. But yeah, so using BERT, I did get better results, but I still haven't sort of hit state of the art yet. So I'm not sure how, when you see the BERT paper itself, like the results they get on the Quora question problem are a lot better than I'm getting. So I'm not sure how they did that, or if the problem that they're using as their benchmark is the actual Kaggle problem, or if they've got a different set or whatever. So,
Yeah.
but yeah, so I've posted on the Slack the link to the notebook. So if anybody wants to take a look, they can go through it and see exactly what I did.
Yeah, thanks. That definitely. So among current group submitting, yeah, the project Banister, and did you say you broke the 1,000 or not yet?
Not yet. I think I'm about 1,010.
Ah,
So
yeah, I'm
I'll
hot
have
on
a
your
party
heels,
when I
but
get
not
into the top 5.
yeah, not yet made it across that line.
Yeah.
I tried Yuri's idea of using sentence BERT, SBERT, and like you, I submitted. I was very optimistic because I was getting very high accuracy in training, and we'll look at that because that's another one of my questions which we discussed a little bit in 224. But I'd like people to take a look and really see whether there's something that can be done. Is I'll share. And it's your notebook modified to use SBERT. And again, like you mentioned for BERT, there's also multiple models for SBERT, which is sentence BERT, and that Yuri had pointed to. So I thought I would try that, since that's just slight modification of your notebook or Gautam's original notebook using USE, but using SBERT and different. And it has, interestingly, SBERT has a model trained for Quora question pairs. And so I used that, which uses Distilbert, and the accuracy I got was pretty impressive compared to USC, and it went up to 94.8 or something on training, 91 point something on validation, but my results were in the same 0.3332 kind of range. So that seems like you'd have to go down to the BERT level or a word level. The other thing which I had planned on trying, but I ran out of time, is this using glove vectors and doing simple averaging, which I'm still wanting to do as a baseline. attempt. And so that's the related thing. And I can, yeah, does anybody else want to talk about their attempts? Gautam, Dinesh, Victor, Yuri, anybody made any other submissions or attempts they'd like to discuss?
No, but I have a question. So you used as pre-trained as BERT. You haven't tried training it, right?
That's correct. I
Okay.
didn't train it. Yep, pre-trained expert, but pre-trained, they have variety of models, and I'll show you the model I used,
Okay.
which was Distilbert on Cora question pairs, which anybody else?
Sorry, Srinivas. I obviously missed the start of the Stanford thing because of our
Yes.
clocks going forward.
Yes.
Yeah, I've got one question about my own notebook that I'm not sure what Joseph said about that. Could I just share
Yes.
the
Go
notebook a
ahead.
second and
Yes,
to show
for
you
sure.
what I mean?
Yes, absolutely. Go for it.
Yeah, so yeah, this is all taken from the TensorFlow example. Yeah, so we've got like the set of training data coming in, and yeah, so like it gets tokenized to split it into words, and then it gets put through the thing to get the IDs from the vocabulary. So we have like all of the IDs for each question. But what I found was in these heat map things that it has, yeah, so on the left hand side, like all of the dotted thing, that there's like each ID for each word in the sentence. But like when I did it with the proper Kaggle sentences, I got the odd one that had a massive amount of IDs. So like it was like maybe, I don't know, 300. So I ended up chopping them off. So here I only take the first 50. So you can see like in this heat map, so it sticks together so you've got like 50 tokens for question 1 and you've got 50 tokens for question 2, which is why this goes up to 100.
Yeah.
But like it also it pads each of them to 50. So if your question 1 only has like say 20 tokens in it, then it'll be 30 bits of padding, and similarly for question 2. And so you can see most of this is purple, which is so most of it is padding. But like if I didn't truncate them at 50, I ended up, this would go to like say 400 or 500 or whatever. And so like the actual sort of contribution of the questions themselves was minuscule compared. So it's ended up I had to truncate. So in some cases I will be sort of chopping the ends of sentences off. So it maybe reduces the
Accuracy.
the thing.
Yeah, but I had a question, Steve. Were you able to look on this? I had a question for you. Were you able to kind of see which sentences gave you that 300 problems, or a histogram of like, but they're just few, like less than a dozen or something, that actually threw the thing off to 300 tokens, or were there a number, or were you able to find what was the cause for their becoming so huge when it gets tokenized?
No, I haven't found that yet. I need to go back and like look at that, but I did a quick look, like just like sort of looking at the number of characters in the sentences and stuff, but I couldn't see any that were sort of massively bigger than anything else. So I wasn't sure why the tokenizer was like giving me ones like a sentence with like say 200 tokens in it. And when you look at, yeah, like so here, this is where it's now sort of used the mask, or it's created the mask. And so like it's easier to see exactly how long things are. When I looked at this in the untruncated one, again, I couldn't see like any yellow lines that sort of stretched the whole width across. So I wasn't exactly sure where that was coming from or what was happening, but
Yeah,
yeah,
because
so I
now
need
that
to look closer.
yeah, now that we're discussing, I remember um, there's EDA, and you had in fact pointed to a couple of them, I think, right? Like if you look at the EDA notebooks that some people have done, they have done the word count because they were using the TF-IDF and stuff. So from that, you'll be able to quickly look at which ones are even very long. But I'm just wondering whether it's the tokenizer running into some kind of a problem that it isn't able to tokenize something and therefore creates this massive. Um, is it when you tokenize that you get the more than 50 that you have to
Yeah.
stop?
Yes,
So
it
I'm just
is. Yeah. So
wonder
yeah,
whether
the
it is the tokenizer.
tokenizer. Yeah. So you can see here for like a sentence like hello TensorFlow, it does start splitting things up, and as you say, like it may be creating strange things here, and yeah, because I couldn't see any sentences that were particularly long, but
Yeah.
yeah, so maybe the tokenizer has done something funny and made a
Yeah,
big
because
mess of.
that's my suspicion. Because one thing I did notice, and I don't even recall why I noticed it, but there's at least one question that I know which has arbitrary punctuation in the middle of a question, which is almost like, somebody cursing or typos or something like that. And I don't know whether it's struggling, tokenizer is struggling with that, therefore sticks one for every character or God knows what. But anyway, that's an interesting thing to pursue, seeing whether, if you get rid of them or there are just a couple or whatever, which is causing the tokenizer to freak out and thereby having to reduce the real thing to 50 type of stuff.
Yeah, so my truncation may be bringing the scores down a bit, but
Yeah.
so
Yeah, 50 is
So
probably too less, I think, because Bird can take in an input of 512 tokens, right? So you could at least give it a limit of 256, and yeah, for each question.
yeah. Yeah, like as I say, like on those graphs, it ended up sort of the contribution of the sentence compared to the amount of padding looked to be like really tiny. And so like that's why I sort of truncated it down just to sort of get it to have a bigger contribution from the actual sentence. But it's something
Yep.
to look at.
Maybe you would get a bigger jump in your score if you stop. I mean, if you don't do this type of padding, maybe.
Yep.
Anyone else? Gautam, any?
Uh, yeah. Yeah. I'm having problems actually trying to get this LSTM to work properly. So the issues are that the scores are kind of random, like they're not consistently increasing or decreasing. It seems to be kind of random, and it's not training that well. So I'm not sure about why. I mean, is it just that LSTM is not powerful enough, or my model is not big enough, or is there some other mistake in my model? I'm not particularly sure of that, because I've had to copy from many different places, and I wrote a few like a lot of the stuff I wrote it on my own, so there's bound to be some things I messed up, so I'll have to look at that again.
Yeah,
And
thanks for
yeah,
posting
score
the
was
notebook.
0.62. Yeah.
That, yeah, that will help get other eyes. I wanted to kind of play around with your notebook as well, which I didn't get to. But yeah, that would, because I think it is, I mean, in fact, a modification of what you're doing was the second idea that the Cora guys shared too, right? It was some
Mm.
combination of LSTM also,
Yeah.
I thought. Yeah, so that's definitely something as to why, or at least figure out the various pieces to get it working would be a good baseline uh, to have as well. Yeah.
Yep.
Anyone else want to share any attempts that they've been able to make on the problem? Okay, if not, let me share a couple of. Um, Let me see whether I can share my notebook. And like Gautam said, and Steve also echoed this. I'm seeing some interesting differences in, I'll just mention them, but let me see whether I can share my, I think it's this guy. Okay. Can you see my screen?
Yes.
Yep.
Okay. So this is what Yuri pointed to, right? This SBERT thingy, this is the sentence BERT. So sentence transformers. So it just uses BERT, but then, on instead of BERT for word pieces and using for word, it does the equivalent of universal sentence encoding, which means it encodes a sentence, but it uses BERT to encode the sentence. I haven't looked at USE yet to see what it uses to encode, but for sure this encodes using BERT. So I did use, let's see, was this it's cloud that I was attempting. This is yours. Okay. So this is the one that I was. Um, so we can see. So I just talked to these 4 different models and kind of mention why I said there are some interesting or strange results. You can see that these two, the NN LVEC NMOD and the NN LVEC. So LVEC was just my code for long vector. So here I'm using USE for these two. And LVEC is just my code for doing not just U and V vector for the 2 sentences, but using U, V, and then U minus V, and then obviously absolute value of U minus V, and then the product of U and V. So that's what I mean by long vector, because my vector becomes 4x because I'm using U, V, and then U times V, and then the absolute value of U minus V. And then these two, the differences are between these 2 rows is the first one was the simple model that Steve had, which didn't have any batch norm, no uh, dropout. It was just a simple, just straight up linear transformations with activation. And what's interesting is you can see that I got a better score with the simpler model than with the model which had more layers and had dropout and batch norm and used all those. Now the difference is obviously in the 3rd decimal point, but it's still interesting that the simpler model without batch norm, without dropout, and with fewer layers got me 331 versus the more complicated batch norm dropout model with more layers was actually worse. And obviously that is with the USE model. Then I use the SBERT for the other 2 rows that I have here. And here you can, the first model is again the LVEC, which is basically, as I said, the sentence encoding of the first question, the sentence encoding of the second question, and then U minus V, and then U times V, element wise. And that one gave me 335, which is, surprisingly close to the USE, about in the ballpark. And the private score is slightly worse, but comparable. But here, I tried first the more complicated model, and then the simp is the simpler model, which is closer but not exactly same as Steve, which is just direct linear multiplication, linear layers with no batch norm, no dropout. And you can see here it actually got worse. So don't it was kind of interesting to me that a deeper layer with dropout and batch norm seemed to be slightly better for the SBERT model, but not the same for the USC models, which I don't know what it says, but I just thought it was interesting because that's not what I would have predicted. And then, and the behavior is different for USC than it is for the SBERT, even though they all give about in the same ballpark scores. So it seems to me, at least even from what Steve did, and that there's a limitation somewhere in this range, unless and there's one other problem I'll show and ask for suggestions, which I mentioned in the 224N study group as well, that I'd like to solicit ideas on. But barring that, it seems like whether you use USC model or the SBERT models, I haven't used multiple SBERT models yet, which is something I want to try because there are a bunch of them that I'll get to in a minute. But before we do that, the thing that I wanted to also ask for questions or input from people is this graph. This is something that I see consistently in, and I'll show you in the maybe in the USC thing too, and it's actually a good thing that Steve added, I believe, in his notebook, or was it you, Steve, or Gautam? I forget, because it was definitely stolen from existing
Which bit?
notebook. This bit on the showing the history and training laws and validation laws and stuff.
Oh yeah, that's the bit out of my notebook. That's what we were talking about. Another thing, yeah. So just be careful because it misses epoch number 1.
Yeah. But see, the point I was getting at is, you see this thing here, the training accuracy is still going up even after. And by the way, this is a 60 epoch run, which I kept consistent with. Just wanted to stay with what Steve had, and you can see that validation loss flattens pretty early, like 10 epochs in, or maybe 15 epochs in. And it kind of like toodles along, and in fact, it's getting worse towards the end, kind of dropping off of where it is, but fractions. But you can see that the training accuracy, sorry, not loss, accuracy, training accuracy continues to increase. And I don't think it's yet flattened at 60. And this gap is something that I think would be worth bridging. At least my recollection is that one of the ways to bridge this is to augment, because this shows a lack of generalization, right? It's continues to improve on training, but it just flattens on validation. So that's any ideas, comments, strategies on how to bridge this gap?
Yeah, if you take a look at your validation loss, you can see like it very quickly starts to rise. Yeah, like after only a few epochs, and like that's what I've seen. It's like, yeah.
Whereas this continues to go down, you see. Training
That
is
is
not
like
even
standard.
flattened.
That's standard overfitting, though, isn't it? So yeah.
And
I had been hoping that so like I tried Gautam's idea of swapping the question pairs to double the size of the training set. I was hoping that that was going to improve the generalization, but I haven't got it to do it yet.
Yeah, that's a good idea. I wanted to try. I saw that in your notebook. And the other thing I was thinking of, which I think Joseph mentioned, but I did try, and that's why I pointed out the slight differences, if you will. And in case of USC, when I added batch norm, when I added dropout, it actually got worse. Whereas your very simple, just 3-layer with no batch norm, no dropout, gave a better result. So increasing dropout is another way. I thought, and my dropouts, for the way I had like maybe 3 or 4 layers, and I had used dropouts of 0.35 and then 0.25, something in that kind of a range. And as Joseph mentioned, I wanted to, and I started with lower figures and I increased it, and I didn't see much of a difference. So that was something else that, maybe I should jack it up to 0.5, 0.6 and see whether it improves. But obviously, that's another knob to turn. But this lack of generalization. So I was also going to go on a hunt of how to augment the data. One is actually what you said, Steve, but are there any other clever ways of augmenting the data to make it better generalized? So that's
I have
something
a
I want
thought
to.
that I'll just throw out.
Yeah, go ahead. Go.
So what Gautam did was I think an interesting idea, but it didn't work. But I mean, switching, adding these duplicate, adding these switched questions. But what if one idea that could be tried, and maybe I'll try it, is to take questions that are already in the database, instead of adding duplicates straight on, just mask out some words in one of the questions and leave the other one intact. and then so that kind of messes it up a little bit, and that might be good for regularization.
Yeah, that's like the like label. I forget what the term is, but yeah, kind of there's one way to play with the input data and kind of tweak it. There's another way to kind of mix up the labels.
Yeah, something like that.
Yeah, that's a good idea. That's
Or,
something
or, or
worth.
take, or select, like, say, two or three words in one of the sentences and replace them with random words, something like that.
Yeah, yeah, those are good thoughts to try, because I mean, I'm thinking this is, you know, definitely indicates a problem of lack of generalization, right? So I was just thinking, what are all the ways that you could help bridge or reduce the gap?
I haven't used it, but I shared the link. Basically, going off Joseph's idea, you can basically put in synonyms, that kind of stuff, replace words. That
Sorry,
gets
Rekal,
pretty.
you're very faint. Maybe is it just me, or are you? Is it
Can you guys hear
bad
me
for
now
others too?
better or no?
Yes.
Oh, okay, cool. I just shared a GitHub repo. I haven't used it, but going off Joseph's idea, that basically replaces words with synonyms and that kind of stuff. So maybe that could help you guys.
Yeah, because I see this pattern. I mean, with different numbers, but this gap between validation and training accuracy is there even in. Let me see whether this is my other notebooks. Yeah, this is also SBERT, but I have other notebooks which show the same problem in USC as well. So this is one thing I wanted to ask Gautam. Gautam, do you see, or when you do the training, do you see that with LSTMs too, or do you plot this and do you see that, or do you see different?
Yep, like I said, I was getting very stochastic, random losses and accuracy, but I was still seeing a trend downwards, even for validation. So I might have to continue that and see where it goes.
So you're saying your validation loss was still going down?
Yes. Let me just see if I can.
Yeah, I can stop sharing if you would
Yeah, I
like.
mean, yeah, sure. Like, but I'm sure that there's something wrong with my model. Yeah. So this was the last time. Can you see my screen?
Yes.
Yeah. It's, I don't know why it's so jumpy like this, but there is a trend downwards.
Yeah, that's good.
And this is the other one. Yeah, even here there is a validation accuracy, there is a trend upwards, but I have no idea why these jumps are coming. Probably because I'm recording the wrong loss or something like that, I'm not sure. But yeah, there is a trend that's upwards, I think. So I might have to continue and see uh, if it gives me uh,
So
good
is it
results
8
going forward.
epochs that you
It's
are?
10 epochs.
Okay.
Yeah, 10, 0 to 9. Yeah.
Yeah, I
Yeah.
think Yeah, Joseph and Rick. Yeah, go ahead, Yuri.
I have a question for Raquel. So how would you use the synonym in this case? Do you have like a... So like basically take the question and replace some words and see if they would match?
So you basically, let's say you had one row. This is my guess completely. Let's say you had one row of data. You just replicate that row and then go in and substitute words in that, right? That's what.
So you increase your training size.
Right, exactly.
On the training side.
Yes.
So one could also try to do it on the test side.
Yeah, sure. Yeah, why not? Yeah, absolutely.
It's similar to the adversarial attack, the text attack. I think you've heard of that, right? The text attack library, where you just replace words by their synonyms and see if the model still gives the right
predictions.
output.
Right.
Yeah. So you're just augmenting your training set.
So I think that library even has antonyms. I mean, that kind of gets trickier, I guess. Like if you have nots, then I guess you can go ahead and replace it with that too. But yeah, I really haven't used it that much. There's something related with sentence too in that. I remember seeing. Towards the middle of that GitHub page, if you see, you can see there's one textual sentence which says contextual word embeddings for sentence augmentations. I don't know what exactly that does, but looks like something that can be useful. Yeah.
So you want to share what?
Sorry. Do you mind pulling up the? I just shared the link in the chat. Do you mind pulling that up?
Oh, yeah. Okay. Let me get my chat orientation. Okay, hang on a second. There. Okay. So opening it now. Okay, can you folks see my screen?
Not yet. Yeah, can see that now.
Okay, so where is
it? So if you just scroll down, yeah, on the README.
Yeah, my graphics is slow, so it'll while to show up.
Yeah, just to answer Yuri's question, this is what it would be like. You have the original sentence and you're replacing it with a synonym. And so you can see jumps over the lazy dog becomes fox climbs over the lazy dog. So you basically get like 2 rows of that data instead of just 1 row. And they have a bunch of ways you can do that, just using the synonym, using a word to vec, whichever is the closest, trying to replace it with that, using BERT and stuff like that.
That's cool.
So you can generate, quite a few options. I mean, variations of your data, I guess, with this. And the question will be now how many words you want to replace, how many words if you replace do make sense, because you can see that in about 1 sentence, you can replace 1, 2, 3, 3 words in that example itself. So I guess that will be a variable to play with. But if you scroll down, now this is the acoustic part.
Yeah, the other kind of, since it mentions it here, I wanted to bring up and that I haven't done is in the SBERT DistilBERT model, there is one model trained on Coro question pairs, but it's multilingual. And I was wondering whether, after I did this and stared at the validation and stuff, I was wondering whether using multilingual itself would help with some kind of regularization, because ultimately all languages aren't similar. but so I intend to try that because there is a model like it says here, multilingual textual inputs. Like that, there's a multilingual Distilbert SBERT model, which is not what I used. I used the English version.
Is the data set that you guys are using for Cora multilingual currently?
Sorry?
Is the data set you guys are using right now multilingual?
No, it's just English.
So would multilingual help? I'm just wondering, like, how would
Whether
that
it'll
help
work.
you?
Yeah, don't know.
Yeah, that would be interesting. I guess, yeah, you just won't be using like certain part of that vocabulary itself, right?
Right, right.
Yeah, should still work,
But
I guess.
It's worth a shot because is it like dropout that where you just start using, I don't know. I mean,
The
it was just
embedding
a thought.
side, right? Yeah, the embedding side of it, maybe, yeah, right. Yeah, right there. So if you look at that augmenter, those are the options. And if you look at textual, you have character-based augmentation, word-based, and sentence-based augmentations, I think. So, yeah.
Yeah, this is very interesting because as you say, it gives you
So
how
if you look
many
at,
and do you replace synonyms?
right, exactly. And if you look from not the last column, but the last but one column, those are the operations that you can perform: swap, crop, delete, or substitute, or insert. So yeah, it gives you quite a bit of variation, but yeah, can't vouch for it, haven't used it.
Yeah, no, but interesting to try, right? Those are the things which ultimately the augmentation is. I mean, if you look at the image analogy, then you want to shake the image, shift it, rotate it. So this is doing something similar in the text word space, right? By substituting antonyms, synonyms, it's kind of playing with the interpretation that BERT or other word embeddings provide. So yeah, this thing of description of feeding surrounding words to BERT, Distilbert, that sounds like it's very to find out the most suitable words for augmentation. So that seems very interesting thing to try.
With your loss curves, could that be an indication that your model is too small? Like the capacity can be grown some more? I'm not sure. Like, is that an easy fix on your side? Can you I think from what I gathered, like with Gautam's model, probably you can just stack some more LSTMs. I'm not sure what you are using. Can you stack some more things on?
Yeah,
which would increase the capacity?
Yeah, that's a good point. The thing is, in the SBERT or USE, the output of the sentence embedding is a fixed size.
Right.
Right. So it's an embedding. So it's a fixed size embedding.
I see. Okay.
I haven't checked whether the size of the embedding for the various models. I mean, that's one thing I mentioned that I haven't yet used variety of models which are available at least for the SBERT thing that Yuri suggested. For USC, it just fits. At least unless Gautam, you tell me otherwise. I thought there's just a single USC model, but there seem to be a multitude of SBERT models.
I see. Okay.
So I could see whether, to your point, it generates a more complicated. And exactly to your point, by the way, Vekil, it did. I saw a significant jump from using just the embeddings, which is for the two questions, versus using the embedding, the absolute difference of the embedding and the element-wise product of the embedding, right? And those concatenated. So that says that it kind of aligns with your input or suggestion of the capacity of the model. Because when I increased that, I saw that go down. I mean, I saw accuracy improve and loss go down.
Okay. The other thing, like just trying to catch up over here. So how this system currently works is you have two sentences in one row and you pass each of those sentences into your models, get a specific output, and then you pass it through a neural network to make your predictions?
Yes, that's at least how that's the way the USC universal sentence encoder usage and the SBERT usages, but Gautam's LSTM is different.
Right. Okay.
And what Steve has done, which so far has yielded the best score, is using BERT to generate the embeddings and then use a classifier based on that those embeddings to generate the results, which
I
have
see.
given it
Okay.
like in the 0.3132 range versus the 0.3334 that we see with USC and SBERT.
Okay. Cool. Yeah, that's a very interesting graph. Like, I'm curious how you could kind of make that go down even more.
Yeah,
The actions to
because
take. Yeah.
that clearly shows a problem that we have to be able to apply some techniques to address. But this is this augmentation is excellent reference. So it'd be cool to try with any of the techniques so far. Any other thoughts or suggestions for things to go ahead?
Something that I was using recently, actually, it's a copy of Amazon's AutoGluon, but that's in reference with a tabular data classification stuff. Like how you said you added in the product and the subtraction, the absolute differences, right?
Mm-hmm.
There, what they do is they pass each row gets passed into whatever network, XGBoost, blah, blah, blah. And then how they do stacking, when they stack, they actually bring back the whole original row of data and concatenate that in. So in your case, it would be like embedding 1, embedding 2, absolute difference of the embeddings, product of the embeddings, and then I don't know, maybe something like the keywords. I don't know if you can extract something like keywords, like probably drop like the and the and the to and all that kind of stuff can get dropped. And maybe just those word embeddings. That gave me improved results in the tabular stuff. I don't know here that could help.
Do you have a reference?
It's the AutoGluon from Amazon. Yeah, let me pull that up.
So I don't have any solutions to share, but I wanted to point to a couple of more resources, maybe after this.
Yeah, go ahead.
Yeah.
Okay.
Go ahead, Yuri. You do post them on.
Oh yeah. I'm gonna post them, but I'm also gonna.
Yeah, go ahead, share.
Yeah, can you see my screen?
Yep.
Yes.
Okay.
Yep.
So so I I saw this paper on Twitter. It was submitted to the same conference, the empirical NLP methods, which is I think mid-November, by the same group that did SBERT. So I haven't read it through, but they basically saying how like they're using their method uses basically embedding vectors and then the combinations from two sentences to compare them. And they referred to another paper, which I'm going to show also from Fair from Facebook, that basically said that instead of doing that, you can actually, in the way I understand it, that you compare all the weights in the network. They call it cross-embedding. And that gives you much higher score. So they introduced a method how they can basically improve bioencoders to like boost score from bioencoders to cross encoders. But then the paper that they're referring to from Facebook was presented on ICLR. It's called polyencoders. And they're basically also saying, this is the paper, they're also saying that cross encoders are very difficult to calculate, but then they're doing some approximation to like a different combination of weights.
Interesting.
And they're doing so yeah, they call it like a global attention features. So they do attention between different parts of the sentences.
So could you explain what that cross encoder means in
I
this?
have not read the paper yet. So but yeah, I just remembered what they did. They basically, I think they used cross encoding to generate a lot more data, like a training data for their bioencoder. That's but again, I haven't looked at details.
Yeah, but it seems to directly, I mean, it seems incredibly relevant, right? Because they're basically trying to augment for multiple sentence problems, pairwise sentence, which is what is our problem, right?
And then the last paper I wanted to show is what something Darian found for product comparison. So there is a similar sort of science. Actually, one thing I wanted to add for this paper, they're actually solving a similar problem. So normally the similarity problem is the information retrieval problem, right? You see, like if it's questions are similar. Or statements are similar, but it's also they actually in Facebook they're actually doing it for dialogue, also because they basically see if like the predicted for the chat for the bots, if the next sentence is similar to what was predicted. So basically, again, I didn't look at details, but like this comes out as in a different task. I thought that was interesting. But then there's a completely different area that's called product comparison. Product matching, and they have a big data set called comes from Common Crawl. So they created it some time ago. So there's a presentation of this paper and the paper itself. I think they're doing something very similar. Again, I haven't looked at details, but I think they're doing something to what Steve did. So it's basically direct comparison between first and second sentence. But the only thing is that in addition, they also did fine tuning on the intermediate training, which is basically fine tuning on the main data, and they're getting some crazy high results. But again, it's a product matching, so it's a different problem. Actually, I think I have. Just a second. I may have. Yeah, I can show I can show the data in a second. But it. I can't find data right now, but yeah, I'll
Okay.
I'll
No,
share
if
it
you can,
also.
you can post it on.
Yeah.
Like that'd be interesting. The papers that you shared to see how and whether we can borrow their ideas and code for the augmentation part, because they seem to be talking about augmenting SBERT and stuff. So we just
Yeah.
let's see. Let me see whether I can bring up Raquel's paper.
I'll just share that screenshot of the image on Slack, and then probably you can just pull up Slack maybe.
Yeah, no, I'm pulling up the paper. Should be up on my screen momentarily.
Okay.
Oh, yeah, there we go. I think should be able to see it.
Yep. You can scroll down to like section 2.5. Again, this was in reference with tabular stuff, so I don't know how much of help. Oh, yeah,
Yeah,
right
but
there.
these cross-pollination ideas are
Right.
interesting anyway.
Yeah, the figure 2, pretty self-explanatory there. And after looking at the Jaron's book about stacking and ensembling, you basically have your input, you pass it through a bunch of these models, you get certain results out there. Now, so just carrying on with that, what they do is that they have that input back in, which comes in, and all that is concatenated along with those predictions. And then you use that whole concatenated vector now, and then again, like pass it through a model there.
I
So
see.
that's what I was
Interesting.
saying.
So that would, in the equivalent, you kind of split it into u.b blah 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 base, which is the unit b, and then predict, and then again concat with input, try again through multiple layers.
Right. Yeah, that just kind of
Yeah. No, it's worth a shot.
Tricky with 2 sentences. I don't know what you would kind of concatenate there. I'm not sure exactly.
Yeah, but that, yeah, it leads. I mean,
there's something, yeah, there.
Yeah, at least it provides the germ of an idea that you could
bring back that
how to
original
apply
sentence
it in
and
this.
use. Yeah, maybe.
Yeah, that's interesting.
Talking to actually Yuri's point of fine tuning, can you do that with BERT? Like, I know with ULM Fit, you can bring in your data and then like make it predict. You just build a language model of that and then use those embeddings. Can you do that like with BERT too? I'm not familiar.
Let Steve, isn't what you're doing, you're not training, are you?
Yeah, what I'm doing is fine-tuning the model. Yeah, so BERT itself has been trained on, I don't know what it's trained on, like Wikipedia or something. And so, yeah, when we use it for the Kaggle competition, we're just fine-tuning the weights already.
Oh, I see. Okay.
I presume it's like training the classification layer at the end of it, but yeah, it fine-tunes the rest of the BERT model, I think.
No, but you're doing it on specific task, right? On the, similarity task or, duplication task. I think you can also fine tune it on the language itself. So in theory, you can have a task that predicts or like finds a word and just continue running it on the core questions.
I see.
And that, in theory, that should improve the score. And then you like fine tune it on specific task. In theory, that should have a better score.
Right, that's what I was imagining too. Like those odd syncrecy
so
words.
in the last paper that I've shown, they've done that, and they showed that they improve the accuracy in their world, but their world is a different, like it's a very different.
Sorry, could you elaborate? I didn't catch. So you're saying train the language model itself, meaning the BERT encodings itself using the Cora question pairs, and then again fine tune. Is that what you're?
So let's
Okay.
say you know how like that was like explained really well with ULM fit, because I think they were the first one to do it.
Right,
So
transfer
they
learning.
basically they took a model that was trained on Wikipedia, then did unsupervised training on IMDb dataset,
Right.
and then they did prediction of sentiments on the same IMDb dataset. So their language kind of became more aware of the IMDb type of language.
Correct. So you can even use your test set data when you're doing that language model training.
So it's an intermediate step. So it's I have not done this myself because, and it's kind of, you know, you need to, like, when you're doing that, you need to make sure you're not like forgetting the original language. So I don't have like knowledge on how to like yeah, it should be a standard task, but I think it's really easy to you know, you could do like you can forget whatever language was learned before. So I don't know if it's necessarily will help you. So that's but um but yeah, especially if your language is different from the original, you know, language, it should help.
Yeah, actually, I mean, now that you mention it, I recall, like for medical texts or legal texts or something, there was this thought that
Right.
when he discussed ULM fit, that you would want to retrain it because the nature of the language is different as it is for movie reviews than it is in Wikipedia. That's the reason he retrained ULM fit on the IMDb dataset, as you mentioned, before applying the classification, right?
Yep.
Yeah.
I think it would be slightly trickier here because we are just having individual sentences. So the CLS token won't get, its weights won't get updated properly because we don't have the next sentence prediction task. So you might have to fetch Cora answers or something and then maybe train that. Otherwise, the CLS embedding won't get updated properly.
CLS is just the classifier, right?
Yeah,
Like,
the
isn't
the next sentence the CLS embedding gets trained by by the next sentence prediction task. So the next sentence prediction needs to have a representation of your entire input text in order
I
to
see.
predict if the second sentence is a following of the,
Follow.
comes after the first sentence.
I
So since
see.
you don't
Okay.
have that type of data in Cora,
Mm-hmm.
that embedding won't get updated.
And typically with Quora, it's I guess it's really is a question usually. Like there is nothing else unless you like pull the answers, for example.
Yeah, yeah. I think that's somewhat of as Gautam points out, somewhat of an issue with BERT, right? Because of the way it is set up to be trained. Which, interestingly, that's. I mean, Steve also saw this, or he shared when he shared the notebook. He saw. Correct me if I'm wrong, Steve. That your original non-trained, non-fine-tuned bird seem to do better than after 4 epochs or something, right?
Yeah, it produced better results after a single epoch than it did after 4 epochs. Yeah, it just seemed to start overfitting massively.
Yeah, so I was actually originally wondering whether what you had mentioned in passing, which is, like just using without fine tuning, is it giving you better results? And if so, why? And I think the interesting thing is what Raquel and Yuri are mentioning is how would, I guess the question abstracted is how do you train Bert's language model itself on, or is it possible to do that in on different type of data where the sentence linkage is not easily available that Gautam is pointing to, right? The follow-on sentence requirement that BERT uses to train. Because these are individual questions versus kind of collections of text like Wikipedia or any document.
I was wondering if you can still fine-tune BERT on single sentences.
I think you can, but the CLS embedding at the end, that gets trained by the other task, right? So the main weights that you need may not get trained.
Mm-hmm.
The weights of all the other tokens that go, the attention weights of all the other tokens that go to the CLS token, those get trained when you take the CLS output and use it on the next sentence prediction task.
Okay. Well, I guess what you can do is you can like train on the language itself, and then still train on, and then still train, similar on the similarity.
With just the mass language modeling you're saying, right?
Yeah. So like, yeah, I don't know if like we'll come up with some. Yeah. Basically, find missing tokens.
Yeah. I mean, that may give a little bit of improvement, but the attention weights that go from other tokens to the CLS token won't get trained.
Mm-hmm. Can you duplicate? No, you can't really duplicate the sentence, right?
No, I think you need a coherent sentences to
More than
for it
a
to train properly.
effect of BERT, I think this is just the lacking of the data set itself because it's not continuous.
Yeah.
So,
but it also shows to me at least, it seems to show a shortcoming in BERT's or taking the BERT model and applying to this particular problem, right? Because these are individual sentences, they're not paragraphs.
Maybe even if you train them on core answers, it could help because the type of language is similar. Maybe the answer,
Yeah.
questions.
Because, but now that thinking about it, as Yuri or somebody pointed out, these are all questions. So actually training it on answers, how much would it help questions? Don't know. I mean, I'm just saying it's another variation of what you're trying to do versus what you're training it on.
could you like train on this questions itself, but like truncate how big your, what is that called? How big your BPTT is? Like your BPTT, if let's say, I'm just thinking of something on the fly here. Let's say you arrange all your sentences based on word count or token count. So, and you arrange them in that ascending or descending order so that you can use that sortish sampler, right? So then when you form that batch, you just have a batch of, let's say, 15, for example, but that batch pretty much has full questions. And as you go towards the down, because you've arranged them in that descending order, you just pad those off after this question mark per se, because they're questions.
Which is what Steve presented or shared when he showed that, I forget the heat map, right? Which is, he hasn't done it necessarily the shortest on top, but he was padding with the 50, and when it's less than 50, he was padding.
I see. And then fine tuning on top of that.
Yeah.
Using that to fine tune rather. Okay.
Yeah. The max tokens that he had the 50 on, the max tokens were 50, and he was stacking them, not necessarily in the sortish sampler, meaning smallest on top order, but in random order, but still padding to the 50 max tokens for anything less than 50.
I see. Okay.
So, yeah. Okay. Any further thoughts or inputs, comments from anybody?
I found the data. I can share it really quickly.
Yes, go ahead. Let me stop sharing.
So this is a small subset. They actually have subsets for like computers, watches, and so it has the ID, then the website that's selling it, the name, separation, another ID, website that's selling it, and then separation, and then 1 if it's the same product and 0 if it's a different product. So in a sense, you're matching this to this.
Is it a character match, Yuri, or?
Well, so the people they created this set, and I think they use like a lot of classical methods. I'm going to post the link to the website, but they use a lot of classical methods, and recently they've been using deep learning to basically to do the matching. Yeah, I don't know the details, but I think it goes by name. That's but so it's a very kind of specific language. So in this case, I can see how fine tuning would help.
Yeah, or even having to train the model on what it sees, right? Because it's so different from a language type of thing that it would have gotten trained on.
Oh, this is very parallel to like individual questions itself, right? Because there's no connectivity between the first one with the next one.
Yeah.
Yep. There is none.
Well, I guess they get it from the same website.
Yeah.
Yeah.
I
don't know if they use the fact. So when I was looking at this similar problem, I'm always thinking of. What I'm trying to do, I'm trying to match sets of names. I don't know if they do that, but in theory, like if they have sets coming from the left, like they probably, although actually they have multiple. Yeah, I think they have. They talk about how they actually label it. I think they do some sort of clustering, and then they like find closest thing in the cluster. But like in theory, if website is selling something, they would post it like they will have unique product. So you're not gonna have you shouldn't have two products matching to one unless it's more generic. So I think that maybe like that sort of relationship is used.
Yeah, in this case, I think the applicable thing would be, as correctly pointed out, what are they doing to customize if they're using, as you showed, they use BERT. So how do they train BERT or fine tune BERT to this task is the most interesting part that could be transferred over.
Okay.
To the questions, because as Raquel was saying, this is like, each one of these is a question.
And they have code also posted, so
yeah, that's interesting. Okay, great. Any comments, inputs? The one other thought I had, and maybe we'll discuss more next time since we're 50 minutes over, is how Hugging Face is, whether using Hugging Face to simplify BERT, or whether they're built in the SBERT USC into Hugging Face. I was just curious whether anybody has kind of played with that yet.
What exactly is Hugging Face, sorry? What is Hugging Face? Just like a library of BERT? implementations or something, or is it something else?
They pretty much distill stuff for you and give you a nice API to use. So it's like they very much use BERT in the back end, but then you don't have to, the complexities and all that is kind of hidden.
It was just like, yeah, like I think
Yeah,
like Joseph showed it in the Stanford class or whatever, and like Hugging Face, you could go and you could select like a PyTorch version of BERT, or you could get a TensorFlow one. But yeah, like in the TensorFlow one that I was using, the one thing that I found about it was it maybe was sort of like a black box where you had like the BERT classifier, but it was like hard to know exactly sort of what layers were there and how it was like sort of training on it. Is Hugging Face something similar then? If you say it's like an API, is it just you stick your sentences in, it gives you an answer back, or do you actually take a Hugging Face model and incorporate it into your PyTorch or something?
Yeah, they have a lot of models, and since it's open, like they have a hub, so basically you can train it on like how you were talking about only lowercase, uppercase, case insensitive, language specific. People can submit whatever the models they have. So yeah, you have to pick a model and then suitable for your task, and then kind of use that API to, for a specific task, you probably spit out an output based on that.
Okay. So if you wanted to run it in a Jupyter notebook, do you download a Hugging Face model, or do you just sort of fire off
you
your
download the Hugging Face model?
Right.
You'll have to bring down your model, the model from them, and then you kind of use it.
Yeah, I shared a simple transformers that is built on top of Hugging Face. I was just checking out their the documentation. It seems to be pretty simple, but I haven't tried it. So they have specific. Yeah.
Go ahead.
No, that's what I was saying, Srinivas. Yeah, please continue.
Yeah, no, that's. I mean, I hadn't tried it either, and so I had questions like Steve of, hey, has anybody tried it? If not, is it similar? Is it? It definitely seems to be a popular way of using these models. So I was wondering why it's that popular and why, and maybe try it, and was curious whether anybody had tried it, and if not, even worth a shot if somebody can try it, because that would be interesting to understand the use model and stuff like that as well. So I just wanted to bring it up as another something to play with, which is relevant to the problem at hand. So something else we could learn in our in our toolkit. Okay, thanks everybody, and I'll post what Raquel's two chat postings are, but request others if they've been referring to stuff. Yuri, I think if you could post your multiple references to Slack, that'd be great. And thanks everybody for joining, and make some submissions next week. And remember, Steve will improve even post. He'll break the barrier of 1,000, probably get over it. So I think we all must put efforts to catching up with him.
Just share that YouTube link by the Hugging Face CEO. Talks about transfer learning and stuff. Yeah. So
thanks.
Yeah.
Okay.